Hello, everybody, and welcome back to another Mr. Farney Earth Science video. In this video, we're going to be looking at the various objects that we found in our solar system. In the previous video, we looked at kind of solar system basics, how the different shapes of the orbits of our planets differ from one another. We learned a little bit about eccentricity. We learned a couple terms like perihelion, aphelion, things like that to kind of give us the basis of understanding within our solar system. And then I believe we finished off the discussion on how we developed the model of our solar system over time, beginning with the Earth at the center, and then eventually leading to what we have today. So we begin by breaking up the solar system into a couple different sections. First, we have our inner planets. These are the 4 inner planets, and we call them terrestrial planets because they are similar to Earth. And they have solid rocky surfaces. From left to right there, we have Mercury, Venus, our home Earth, and then Mars right there. Those are our 4 inner planets, our terrestrial planets, similar to Earth, rocky surfaces. Starting with Mercury, this is the planet that's closest to the sun. It has no moons. It is tiny, has very little atmosphere to it, and the temperatures are very extreme swings. During the day, it is about 800 degrees Fahrenheit. That's really hot. Keep in mind that it only takes about 500 degrees to begin cleaning your oven. Most ovens have a clean setting on it, which is about 500 or 550 degrees. Really hot. I believe pizza ovens are about 700 degrees. Nighttime dips the opposite direction, minus 280 degrees Fahrenheit. It is very, very cold there at nighttime. Has a very small magnetic field. So Mercury, that's our closest planet to the sun. Very extreme temperature swings there. Venus, it is our evening morning star. What does that mean? It means that Venus in our sky, we can see it very early in the evening and very early in the morning. It's kind of low in our altitude in our sky. It's the brightest planet in the sky because it's the closest one to us. That's why it is. Like Mercury, Venus has no moons. It's in retrograde, which means it spins backwards in comparison to us, how our planet spins. It does have an atmosphere, and because of how Venus's atmosphere is set up, and we've kind of spoke about this previously in this class, it has what's known as a runaway greenhouse effect, in which there is a lot of carbon dioxide making up the atmosphere of Venus along with other gases, and because the average temperature on Venus is about 868 degrees, making it the hottest planet in our solar system. There have been a few probes called the Russian Venera probes that have actually landed on the surface of Venus. However, because of these extreme temperatures, they've only really lasted about 23 minutes was the shortest one, and 2 hours was the highest before the technology on those probes kind of gave out. Here are some surface pictures that were taken by those probes. The top one is the color on the surface of Venus, and the bottom one is the color with those atmospheric effects removed. So this is what the surface of Venus looks like. It is a rocky planet, despite the fact that it is really, really hot, and that atmosphere is full of all of those gases. We get to Earth, we live here, we know what's going on. We got one moon. It is the perfect distance from the sun. It has a perfect rotational period. It contains water, solid, liquid, gas. It has a mild greenhouse effect, which is good because without the greenhouse effect, we wouldn't be able to survive. Too much of a greenhouse effect, we become like Venus. So this is also the only planet remaining in our solar system that has plate tectonics. There's some evidence to suggest that that wasn't always the case, but currently we are the only one left with plate tectonics because we have that really warm core. We got a lot of convection going on, driving our plate movement. Thank you, Harry Hess. Thank you, Alfred Wegener, for figuring that out. But again, Earth, we know what's going on there. Mars, pretty cool. We got 2 moons. It is the planet within our solar system that we have the most explorations in the past and currently going on the surface of the planet. Very thin atmosphere, ice caps on the poles. So we have ice caps, we have ice here, so we have frozen ice on the planet. We got some carbon dioxide, so we got a little bit of a greenhouse going on here. Again, we have a thin atmosphere, so it's not a really extreme greenhouse. We got some mountains and ancient lava flows that suggest Mars might have had plate tectonics at one point in the past, and it no longer does. We're studying why is that the case? Why does Mars no longer have plate tectonics? It has a couple really cool geographic features. We have the Valles Mariners, and I'm sure I'm mispronouncing that, which is 10 times longer and 3 times deeper than the Grand Canyon, if you want to talk, surface trenches. And then it is the home to the highest mountain in our solar system, Olympus Mons. It is 3 times taller than Mount Everest. I believe Mount Everest is 28,000 feet. So 28 times 3, that's really high up there. It's about 80-some thousand feet in height. So it's also bigger than Colorado. Like the mountain itself is larger than the state of Colorado. Very large mountain. I believe it is a very large shield volcano. If my brain is working correctly. Fact check me on that one. That's Mars. Here's a picture of it. Outer planets. So that's all we need to know about the inner planets. Mercury, Venus, Earth, Mars, some basic facts about them. Outer planets, these are our gas giants. They're really, really large. They have gas or liquid interiors. They have tiny solid cores. Some of them have ring systems, many satellites. Now, it doesn't mean that we've sent satellites there. It means they have many natural satellites like moons. And we refer to these as the Jovian planets. So our terrestrial inner planets, Mercury, Venus, Earth, Mars. Our Jovian outer planets, our gas giants, are Jupiter, Saturn, Uranus, Neptune, right here. Jupiter, Saturn, Uranus, Neptune. Sorry, Pluto, you didn't make the cut for the Jovian planets. It's okay, we'll get there. Starting with Jupiter, Jupiter is cool. It's the largest planet in our solar system, made out of mostly hydrogen and helium. Here's the cool thing. It's made out of mostly hydrogen and helium. I was watching a video not too long ago that if you were to put a black hole at the center of the core of Jupiter that's no larger than the width of one strand of your hairs, because of how strong the gravity is in a black hole and the abundance of hydrogen and helium here, it would be enough to kickstart fusion and it would turn Jupiter into a star. So that's just a really interesting aside right there. It rotates very, very quickly for how large it is, 10 hours in rotation. It has some very extreme convection that goes on there. We have belts of dark, warm, sinking air. So kind of the darker colors here on the planet here, like the darker oranges, that's sinking air. The light color is rising air. And because of the extreme rotation in these extreme large areas of high and low density air, we get extreme storms on Jupiter, like our giant red spot storms. These last generally more than 300 years worth of time with wind speeds over 450 miles an hour. Putting that in perspective, the tornado scale, for F5s is just over 200. So this is more than double the strength of an F5 tornado that is massive in size. There are some pictures of these red spots kind of compare and contrast. About 8 days apart here on the bottom right-hand side there. Thank you, Hubble, for the pictures. Jupiter also has a ton of moons. We got 63 natural satellites in Jupiter. So Jupiter is a really cool planet. That's why it's my 3rd favorite planet. Saturn, 2nd favorite planet. It is very odd density, where the density on Saturn is less than water. Extremely strong magnetic field. That's a really cool, important thing here with Saturn. It's about 1,000 times stronger than Earth. We have rings that are made out of dust and sizes of particles like rocks and stuff like that that go up to the sizes of houses. So a combination of really small and really large particles. We have 7 major rings with Saturn here. Again, like Jupiter, it has a lot of natural satellites, 62 moons, and it's home to Titan. It is a moon that we have in our solar system that has an atmosphere. We have methane gas exists in a gas, liquid, and solid state. So our moon Titan with that atmosphere, that's one of the places scientists are looking to see if there is some sort of bacterial life that is living there. Really interesting spot of Saturn. Uranus, it's blue color because there's a lot of methane gas here. We have a small atmosphere that's made out of predominantly helium and hydrogen. And it's cool because Uranus, it rotates on its side. So whereas we rotate kind of like 23.5 degrees, Uranus is almost perfectly sideways in how it rotates. About, a third of the moons of Jupiter and Saturn, but still many, many moons, 27 moons found in Uranus. So Uranus is cool, rotates on its side. Then we get to Neptune, very, very windy here. Like that of Jupiter, it's got these spot storms. So we have the Great Dark Spot Storm here on Neptune. And it has atmosphere belts and zones like Jupiter. So makes sense that if we have these different belts of cold sinking air, warm rising air, we got that huge extreme in densities, that we're going to get really strong storms on Neptune. Fewer moons, only 13, but it's the home to Triton, another moon in our solar system that has an atmosphere, has some geysers. So again, like some of the other moons that we have, very few in our solar system have an atmosphere. Triton makes that cut. We have other solar system objects beyond our Jovian planets. We have this thing called the Kuiper belt. It is this kind of thin belt. It's almost like our asteroid belt that hangs along outside of our solar system. This is where we find Pluto hanging out at the very edge of our solar system. Pluto is an object found in our Kuiper belt that, is orbiting our sun. Its orbital path is offset that of all the other planets in our solar system, and it hasn't cleared away a lot of the debris in its orbital path. That's one of the reasons why they make the argument that Pluto is not necessarily a planet. All the other planets in our solar system have cleared away all the space debris in its path. Perhaps sometime in the future, when they kind of recharacterize what's a planet, what's not a planet, they'll say, hey, maybe we'll switch Pluto back to a planet once it has cleared out a little more of that space debris. We also have this thing called the Oort cloud. So if the Kuiper belt is just kind of like a ring of space debris, like rocks and material and stuff like that, that's kind of in line with the orbits of our planets, think if we were to put that belt inside of a ball, and in that ball is suspended all like the same kind of material all over the place, more rocks, more dust, more stuff like that, in kind of a ball form. That's the Oort cloud. So the Kuiper belt is kind of a belt that parallels our solar system, where the Oort cloud is a sphere in which that Kuiper belt is located within. And what's cool about the Oort cloud is that's where most of our comets and stuff come from. Some come from the Kuiper belt. Most comes from the Oort cloud, where some of the stuff floating around gets grabbed by our sun's gravitation and starts flying in and doing interesting things. So, little more talk about Pluto and his friends. Several large objects beyond Neptune hanging out in the Kuiper belt that kind of rotates. In 2003, we discovered this object that we called Eris, which is larger than Pluto. There's pictures of them here for kind of just some size. We have Pluto and Charon and Eris's moon, Dysnomia. Ceres is the largest object in the asteroid belts. So Ceres, is before Jupiter, between Mars and the asteroid belt is where we have Ceres, this dwarf planet. It's the largest object in the asteroid belt, but it falls under the new classification of dwarf planets because, again, it hasn't cleared that space. Maybe when Ceres clears the space in the asteroid belt, we can, reclassify it. But again, like Pluto, a lot of space junk in its orbit. So we have many objects in the asteroid belt that are large. Same thing with the Kuiper belt, large, that they just haven't met the criteria that we've established for planets. It's okay. They'll be fine. Second and last thing we'll talk about are kind of asteroids. Asteroids, there are thousands of asteroids in the asteroid belt. That's why I call it the asteroid belt. Some asteroids have their own satellites. So we have some asteroids out there, non-spherical shaped objects that have kind of their own natural satellites orbiting it. If you take the total mass of all the asteroids in the solar system, put it together, it is 0.08% of Earth's mass. So there's a lot of stuff spread out there, but if you combine it all together, it's not even 1/10 of 1% of the mass that makes up Earth. So it's really spread out there. When an asteroid gets caught in the gravitational pull of a planet, it might start heading toward a planet. And that's where we get these terms for rock that enter our atmosphere. So if an asteroid gets pulled toward Earth, that's out in deep space, once it enters Earth's atmosphere, we classify it as a meteoroid. Once it begins burning up, we call it a meteor. And then if it doesn't completely burn up and hits the ground, we call the ones that make impact meteorites. So meteors don't make impact unless, you know, they don't burn up. If the meteor totally burns up, it never becomes a meteorite. Meteorite, meteors, if they don't burn up, they'll become a meteorites. So this is kind of like all squares are quadrilaterals, but not all quadrilaterals are squares. All meteorites were meteors, but not all meteors will become meteorites. That's kind of how that works. So make sure we know the difference between these terms. Comets, the last thing we're going to talk about, they're very small icy bodies. They have highly eccentric orbits. So high eccentricity means it's really flat, it's really elongated. And then some comets, like I said earlier, some come from the Kuiper belt, but most of them come from the Oort cloud, just kind of the allowance of more material kind of floating all around our solar system, not in that flat belt shape. Once a comet comes within 3 astronomical units of the sun, so about 3 times the distance from Earth, begins to evaporate, which gives its tail, and it forms, you know, the head of that comet that we see, and it may have more than one tail. Some of them have more than one. What's cool is you know the direction the comet is going depending on where the tail is. So if the comet's moving toward the sun, tail will trail behind it. If the comet's moving away from the sun, the tail will get kind of pushed away from it. So the tails are always pushed away from the sun. That's kind of a neat thing. So you might have some tails of the sun that are going like away from, so it almost looks like the comet's flying backwards. So it's kind of like an optical illusion there. Some comets repeatedly return to the inner solar system, like the Hale-Bopp. That's one of them. They leave behind a trail of particles behind them, like a lot of like dust, maybe some ice in its path, maybe just chunks of the comet itself. And then when Earth passes through that trail around its orbit of the sun, those particles will burn up, and that's how we get meteor showers. So that's really cool. That's why we have annual meteor showers sometimes, and how we can predict when that's going to happen, because we watch where the comets move in orbit around the sun. We know where that trash is in our orbit, so we can say, hey, when we get to this point in our orbit, we're going to be going through debris left by XYZ comet, and we'll get some meteor showers. Really cool. Here's the last slide we're going to talk about, is just kind of the structure of the comet. You should know this. It's only 3 parts. You have the nucleus, which is the head, the center of the comet. You have the coma, which is that cloud of gas and dust that surrounds the nucleus. So we have the nucleus, cloud and dust around it, with coma. It's like that energy shockwave kind of looking thing. And then we have the tail that extends from the comet, points away from the sun. Always points away from the sun. So a lot of stuff in this video, a lot of really cool stuff that you didn't know about, you know, our local space neighborhood. Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. We got the Kuiper belt. We have the Oort cloud. We have asteroids, meteors. We have comets. We have dwarf planets. All these things are in play. I suggest you guys go back, rewatch this to kind of clear up some stuff. So that's going to do it for this video. If you have any questions, please go ahead and ask. If not, take care. I'll see you guys in the next video. Bye-bye.